Okay, going on page 37 when we're done. Oops. Page 37. Okay. So, just a couple of definitions. We got the beginning stuff up here. This actually isn't new either. We talked about it. There just wasn't any place to actually write it on there. We had a bunch of postulates, so we're going to actually write down the definition of a postulate. So a postulate, or another word for a postulate is an axiom. You will hear postulate way more than you will axiom, but I want you to know if you hear it, it's the same thing. So a postulate or axiom is a statement that, okay, so don't worry about trying to fill in the blanks, but just what is a postulate? True. Very good. True, but we can't prove it, right? So we can't prove that it's true. We can't prove that it's false. So we just accept it as true and move on, right? So it is a statement that is accepted as true without proof. So the way I said it the other day was an accepted statement of fact. It's another way to state that. But we just say, hey, we agree it's true. It's okay that we can't prove it. Okay. All right. And then the other concept that talked about and didn't write down is intersection. Okay, because we don't want to just think about an intersection of something as it passing through, because it may not pass through. So the intersection of two or more geometric figures is the set of points that they have in what? Common. Good. All right, so it's a set of points that they have in common. It's what they share. Okay. Everybody okay with that? All right, so we're going to look at some questions that we have to answer with always, sometimes, or never, and we have to justify with a postulate. So when you're trying to answer an always, sometimes, never question, it's kind of like true, false, but we've thrown a third piece in there. Maybe drawing some pictures of the different things that could happen could be helpful. If there's only one way it could ever possibly happen, then it's always. If you could make more than one way where something could happen, then it's sometimes. If you can't even make it happen, then it's never, right? That's kind of how you think through them. So let's look at this first one. It says there is exactly one plane that contains points A, B, and C. Okay, so think without speaking. Okay, think to yourself. There's exactly one plane that contains points A, B, and C. Think about whether you think that would be always, sometimes, or never. You can jot yourself down a little picture if you need to. You don't have to. But that is one of those things where maybe drawing it out might help you, or maybe not. And then whether it's always, sometimes, or never true, then you also need to have a postulate to back that up. That's why having your notes out would be helpful, so that you can look through there and see which one, regardless of whether it's always, sometimes, or never, could back up what you're trying to say. Okay, so think through that. I'll give you a second to think. All right. So Donovan, where is Donovan? All right, so what are you thinking, Donovan? Always, sometimes, or never true? Always, okay. So do you have a postulate to back that up? Okay, so look at your notes because you need one. Wait, I don't understand the question. What was the postulate? Oh, it's the last one you wrote down in your notes. Okay. Okay, so read it to me. What does it say? Okay, so that's because of that. That's why you're telling me that this is an always thing. There's exactly one plane that contains points A, B, and C. Sometimes. Why did you just change it to sometimes? Or non-collinear, right? Because you don't know, because you don't have points A, B, and C. So since what that says is there's exactly one plane through three non-collinear points, this doesn't say whether they are or not, right? So if they're collinear, that's one thing. If they're non-collinear, then there's exactly one. Okay, make sense? So Donovan, now your final answer is Always, sometimes, or never? Sometimes. Okay. So we're going to put sometimes. And then we have to back it up with that postulate that says through any three non-collinear points, there is exactly one plane. All right, but that's not enough here, because when it's sometimes, that means it could work and then it could not work. So that just tells you when there is one, right? But how many planes, okay, I want you to think without speaking, how many planes go through the 3 points if they are collinear? Elizabeth, where are you? All right, so how many planes would go through the points if they were collinear? 0? So if I have 3 points and they're in a line, no planes are going to go through them? Those 3 points, huh? Just one if they're collinear? Because this says, then this wouldn't be sometimes. Through any 3 non-collinear points, there's exactly one plane. So I wouldn't have to say that if they were collinear. So look down on your notes, find your notes where we talked about planes and infinite, okay, right? Because remember your, like a spiral, right? All the pages in the book are planes, and then the spiral is the line, and so there's an infinite amount of them, all right? I'm going to say but, so comma, but through, right, through any 3 collinear points, there is an infinite number. So you have to kind of planes, yeah, an infinite points. So through any 3 non-collinear points, there's exactly one plane, but through any 3 collinear points, there's an infinite number of planes. So that's why it's sometimes. So if it's sometimes, you have to explain when it does work and when it doesn't work. Okay, we good? Any questions? All right, so let's look at the next one. It says points E and F are contained in exactly one line. Think without speaking about whether or not it would be always, sometimes, or never, and you're going to need a postulate to back you up. Look through your notes. Staring at me is not going to get you anywhere. Gluing stuff in when you're supposed to be doing something else isn't going to get you anywhere either. So put the glue stick up, turn to your notes that you're supposed to be looking at. All right, Nina. Where's Nina? All right, so what do you think? Always, sometimes, or never? Always? Okay, and what you just said is a true statement. Any 2 points are collinear, right? But if there is a, yeah, because it says right here, explain your answer with a postulate. So although what you just gave me is a true statement, there should be a postulate to back you up also. There you go. Okay. So this is always, because through any 2 points, there is exactly one line. So right now, because your notes are in front of you, I would expect that you could give me word for word what I gave you. But then on a test, if you can't split this out back to me word for word like I wrote it, that's totally fine. As long as you have the important words in there, like exactly, like only. You can't say things like I see people say 2 points make a line. No, 2 points don't make a line. 2 points are 2 points. That's what they make, is 2 points. You can't say there's one line through the 2 points. True statement, but it's not enough to be a postulate because you have to have that word exactly in there. Does that make sense? So it has to be close. Yeah, you have to use, if you could say only instead of exactly. You could rephrase the sentence, but just like anything else, it still has to have all the important stuff there. You with me on that? You good? All right. Two lines intersect in two distinct points, M and N. So think without speaking about whether that's always, sometimes, or never true. And make sure you have a postulate to back you up. Anthony. Where's Anthony? All right, so what are you thinking? Very good. All right, so this is never, because if two lines intersect, they intersect at exactly 1 point. I also want to make sure that you understand why we have to, I try and make this stuff as less wordy as I possibly can, but we can't just say two lines intersect at exactly 1 point. Because if that's true, and then I have like these two lines going to intersect? No. So that's saying that these two lines are going to intersect at 1 point, right? Exactly 1 point. So that's why we have to put the if two lines intersect, because not all of them do, right? So it might seem weird sometimes why we have to say the extra stuff, but there's always a reason. If we don't need it, we're not going to put it, okay? But we have to say if they intersect, then this is what happens. All right, we good? Any questions at this point? All right, so let's turn the page. And it's helpful not only to maybe draw a picture if there isn't one there. If there is one there, writing on the picture, drawing things on top of the picture, shading in whatever it is you're looking at, those things can be very helpful too. Remember, there are matte pencils or colored pencils in your supply box. You're always welcome to use them. You may not like using color. If you want to, they're there. If you don't want to, that's fine. There's different ways to do it. Just be careful when you are shading things in that you don't shade it so dark you can't even see what's there for the next thing, especially if we're going to use the same picture over and over and over again. Okay, so here it says, using the figure, answer the following questions and explain your answer with a postulate. If there is not a postulate that fully explains your answer, be sure to give clear explanation using information from your notes. Okay, and I'll kind of clarify what that means here in just a minute and kind of give you some of the what not to do's. So once you look at this picture, and look at number 1, it says, are points S, O, and M coplanar? That's a yes or no question. Think without speaking. And then you're going to have a postulate to back up your answer. Okay? Miguel, where's Miguel? Okay, what are you thinking? Yes or no? Yes. Okay. And are you sure? You sound very confident. Okay. So do you have a postulate to back you up? Okay. Y'all agree with him? Yes. Just because I ask you if you're sure doesn't mean you're wrong, okay? Also, when you answer a question, if you're waiting for me to react so you can tell if you're right or wrong, it's not going to happen, okay? I'm like a rock star at that, okay? You're not going to know if you're right or wrong by the look on my face. If I asked you, are you sure? It makes you question like everything you've ever thought in your entire life, and then you want to change your answer. That's why I want to know if you're confident, because if you're confident, it's not going to shake you, right? But yeah, sometimes if I ask you, are you sure, you might be wrong, but just because I ask you that doesn't mean that you're wrong, okay? So keep that in mind. I want you to think about, well, I don't know, maybe make sure you're confident in what you got. But yes, okay, very good. So the answer is yes. And see what I got last period, I did get a yes, but they didn't give me the postulate like you did, even though it clearly says postulate. They said any 3 points are coplanar, which is that a true statement? Yes, and that's one way to look at the answer, but is that a postulate? No. Okay, so the postulate is right. That's good. So we're going to say through any three non-collinear points, there is exactly one plane. And honestly, the more you write it, the more you think it, the more you read through your notes, chances are pretty good you can repeat that just like that. Not because I want you to be able to repeat it like robots, but if you're writing it over and over again, it's probably easier just to say it that way than trying to rephrase it. Okay. What? What did I put? Three non-collinear points. Yes, one plane. All right, so if you want to draw that in there, which again, you don't necessarily have to, we do not connect the dots. Okay, you do not connect the dots to get SOM. It doesn't make a triangle. The plane looks like this. Okay, there's the plane that contains SO and M. Goes diagonally through there. No, not necessarily. Planes don't really have a shape because they go on forever. We do draw them as parallelograms, kind of just to show that they're slanting like it goes on forever. In this case, because this is a rectangular prism, they end up looking like rectangles, but I can make a triangular prism and they might look like triangles or different things like that. Does that make sense? So that's just like part of the plane and it's representing it. Does that help? Yes, ma'am. Huh? Go ahead. Try and go on a different class period from now on, though. All right. All right, so now let's look at this. How many planes contain points S, T, and R? So think without speaking. How many planes contain points S, T, and R? Oh, Xavier, where are you? Okay, so what are you thinking? How many planes? Infinite. Okay, are you sure? And is there a postulate that really backs you up? Okay, good. So there's not really a postulate that kind of directly goes with that. But did we write something down that kind of helped you know that? Did we write down something in our notes about the collinear points? Oh, shoot, I gave away my next question. Yeah. Good. So it's kind of a, so see it says if there's not a postulate, then be sure to give a clear explanation. Okay. So you can't say like for instance, when it says our points S, O, and M coplanar. The reason I get sometimes is because they're on the same plane. Well, duh. That's just the definition of coplanar. That didn't tell me why they're coplanar, right? So the fact that we've got an infinite number of planes is good. So let's write this. So there's an infinite number of planes. And it's because the points are what? Collinear. Good. So then we can say through any three collinear points, there is an infinite number of planes. You could say stuff like it's because the points are collinear, and then that's fine too. But when I ask you how many planes contain them, the answer can't be 2 because that's what's in the picture, right? There are either an infinite number or 1. Those are only 2 options from one extreme to the other. So there's either 1 or there's an infinite amount. There's nothing in between. Okay. Any questions? We good? All right. So find the intersection of planes LON and PQM. So we'll think without speaking, name the intersection of the planes so you can, remember, LON, I don't go and connect the dots like a triangle. LON is the whole top of the prism. PQM, thank you, PQM. That's like the front. See, if I didn't use different colors, then it would just look like I shaded in a whole bunch of stuff. All right, so what is their intersection? Gabby, where's Gabby? Okay, What is the intersection of those two planes? Point M. Okay, do you have a postulate to back that up? Where'd you get that postulate? Is that what your paper? Is that what her paper actually says? What she just read? That's what it says. Can you? Is that what her? Look at her paper. Is that what it actually says? That last word? Yeah, you didn't write the right thing down, sweetheart. Exactly one what? Line. Change that on your notes. Okay. Exactly one line. Okay. So then, now Gabby, tell me what is the intersection of those two planes then? Line LM, okay? Y'all agree with that? Do you see a line on this picture? Okay, is there a line that's drawn on here like already for you? No. Okay, so do you still think it's a line or should it be a line segment? What does that postulate say again, Gabby? So would answering it with a line segment make any sense? No. Would answering it with a point make any sense? No. It made sense to Gabby because she had it wrong in her notes, but that's okay. We fixed it. That's why we're doing this. Okay. So you did good following the postulates that you actually had written down. It just wasn't the right one. All right. So even though it looks like a line segment and these look like rectangles, don't they keep on going? Which means this keeps on going too. So the postulate says they intersected a line. I didn't ask where the two faces of the prism intersect. I asked where the planes do. So it is a line. Good. It is line LM, written like this. Yeah, I can make you question everything. I am pretty good at that. All right. Not to be mean, but it's to make you think, right? No, that it's not because it's mean. I'm like, haha, you were wrong. Nothing like that. All right, so if two planes intersect, they intersect at exactly one line. So one of the things, anytime you have to explain, the most common thing I hear from people is, okay, well, I can answer the question, but I just don't know how to explain it. Okay, so the truth is, you can't answer it if you don't know how to explain it. Even though most all questions that ask you to explain things ask you for an answer and then an explanation. If you can't write the explanation down before your answer, then you don't know how to answer the question. Because that's what the explanation is. It's telling you what it's supposed to be, right? So when I ask you where two planes intersect, well, you should be thinking, all right, well, if two planes intersect, they intersect at exactly one line. That right there tells you your answer has to be a what? A line. So answering it with a line segment, answering it with a set of points, answering it with another plane, or any of the other wacky, weird stuff I see sometimes makes absolutely no sense. And especially when your postulate is right and your answer is from outer space. Like, I don't know how you just told me it's supposed to be a line, but you gave me something else, you know, things like that. So in reality, anytime you explain, you should be able to do the explanation first and then the answer. And if you think about it that way, it'll help you actually answer the questions better. Okay, we good? All right, so now let's look at, we want to name the intersection of plane MQR and line ON. So find those things. I've got to go check since we're on activity schedule, I forgot to look at what time we get out of here. I don't remember. The class isn't shortened, it's just done at a different time. Okay. All right. It doesn't matter. I'm the only one that needs to know that. Okay, so B-Win. Name the intersection of plane MQR and line ON. Say that one more time. Line NR, okay. Do you have a line NR? All right, so it is plane, plane MQR, and line ON. Okay. All right, so they intersect at line NR? Point in? Okay. So, see, all I did was shade it in and draw the line in, and she was like, oh, never mind. So if you actually do that when these questions come up, you've got it in front of you. Does that make sense? It makes a huge difference for you to actually do stuff. Yes, sir. Oh, absolutely. Yeah, you'll probably have to, I'll have the supply boxes like in the back, so you'll have to go and like grab some out, but absolutely, you could use color on any of them. Sometimes, you just have to go get them yourself, but that's fine. Absolutely. Huh? On the STAR test, you can too. Mm-hmm. You can use colored pencils, you can do all kinds of things. All right, so we've decided, she decided to set it as point in. All right, so B, is there a postulate that backs that up? Okay, so if two lines intersect, they intersect at exactly 1 point. Is this two lines intersecting? The previous one, you have to tell me what you mean by that. Is this two planes intersecting? No, this is a line and a plane intersecting, right? So look at where we talked about lines and planes intersecting. It would have been on the front of the second day, bottom left. Okay, so but in this case, are there 2 points that are in that plane? Like that's the closest one, but does it actually follow this, like really apply to this? It doesn't. Okay, so there's not a postulate that directly applies to it, but on that same row in your notes, do you have this situation occurring? Yes. Okay, so V, what does it say there? Nope, you're on the wrong line of the notes. The same line of the notes of the postulate you just read me. Go to the right. Good. All right. So if the line passes through the plane, does this line pass through the plane? Yes. It doesn't if you don't actually extend it and make it a line. They intersect, but don't like pass through. But since ON passes through the plane, that's what makes it the point. Okay? What you can't say in something like that is things I hear like, that's where they touch. They touch? No, they don't touch. That's not even a geometric word, right? Okay, we good? All right, so do P and N determine a plane? Think without speaking. And Elijah, where's Elijah? All right, so what do you think about that one? Do P and N determine a plane? No? Okay, so why not? There's a plane? There's exactly one plane. Okay, good, because that A plane or exactly one plane is going to make a difference here. So to get the exactly one plane, I have to have 3 non-collinear points. Do we have that? No. Okay, but are points P and N coplanar? Yes. Yes, sir. Okay. All right, so this is it. So instead of having to write it again, on a test, yes, you would have to rewrite it, but just for the sake of time, whatever, we can just draw an arrow down there. And that's okay. You can write it. There's nothing wrong with writing it. I just trying to save us some time and some writing. You just draw an arrow from the first one because we wrote it out the first time, and so we don't have to want to have to rewrite it a bazillion times. Okay, we good? All right. Yes, sir. But it doesn't necessarily mean there's a line and not a plane. It just tells you there's a line. Does that make sense? Like if the postulate said through any 2 points there's exactly one line and nothing else, then yes. Okay, I kind of see where you're going with that, and that's not as bad as some of the things over here, but it's not really specific enough. Okay, it's a good question. Anything else? All right. So how many planes contain LO and line LO and line OS? And my little line symbols somehow jumped up. I don't know how that happened. But when it asks you a question like that, it's asking about them together. Like not how many through one and how many through another, but them together. All right, so think about it that way. So we're looking at line LO and OS. Okay. All right, so how many planes contain those two lines? Joshua, where's Joshua? Okay, what are you thinking? Zero? Because? Okay, yeah, you need 3 non-collinear points to make a plane. But look up here, line LO and line OS. So you're telling me there's not a plane that contains both of those lines? Okay. So how many planes contain those two lines? Only one, okay. So I couldn't have another plane go through those two lines at the same time? Like a different plane? Okay, so do you have a postulate to back that up? Okay, that's all right. You can't really make up your own postulate, but nice try. But you could probably make one up that said like that. Okay, but let me ask you this. When you first said no to me, and you said no because you need what? Okay, so do you have 3 non-collinear points here? You see that? Because they do share a point, right? And then they each have at least one other point that they don't share. So do you have 3 non-collinear points to get your one plane? Yes, okay, good. So your answer is 1 and not none. But for the same reason that you tried to tell me, we can just draw another arrow because it's the same thing instead of writing it over and over again. Okay? So does that make sense? Again, not really legal on a test, but I also probably wouldn't make you rewrite the exact same thing over and over again. But just want you to see that. That's a 1. It says how many. All right. Yes, sir. No, that's why I said no, not on a test. You'd have to rewrite it. I'm just doing that on our notes. All right. Not on homework either. All right. So is line OM, because really it helps you to rewrite it over and over again, but we just don't have enough time in class to do that. So, all right. Is line OM in plane LMN? Yes or no? Haley, where's Haley? Okay. Is line OM in plane LMN? Yes or no? Yes. Yes, we do. There's not a line there just because of the way the spacing works on the paper. But all right, so Haley, you said yes. So line OM in this plane, you have a postulate to back you up. Is your name Haley? I said, is your name Haley? Didn't you say no? Somebody said no. Do you have a postulate? Well, I don't know. What's the first one? Yes, except what you said to me is, I don't know if that's exactly what's on your paper. Read it one more time. Okay, good. You said line the first time. That's okay. I wanted to make sure you had it written right. Yes, yes, very good. So if 2 points are in a plane, the line containing them is 2. Okay. Everybody okay with that? You good? Okay. All right, so let's look at the next page. And it does say on there to explain with a postulate, but we're actually not going to explain these. So I want you to look at these while I start to hand out the homework. We still have time left. I'm just going to do this. I want you to think through these See if you can write some things down, and then what I write down it may be different than what you had. Doesn't necessarily mean that yours is wrong. Try and answer as many as you can. I'll probably stop you before you're actually done. But okay, so let's look at these. First of all, make sure you understand the picture, right? We've got two intersecting planes. It's like the dividers we used yesterday when you tested, right? That's why it's dotted, because it's like behind it and you can't see it. 3 points that determine plane Q. In order for them to determine plane Q, what kind of points do they have to be? Non-collinear. Good. So could we use B, W, and Z? Yes. And when you name points, you can just list them like this. If you put them in a different order, that's fine. Could I say, now I'd only have to name one set of 3, but could I have said U, W, Z? Is U in plane Q? It absolutely is. Don't the planes go on forever? Yes. Since it's in this line right here, when Q goes up, isn't U part of it? Okay. X may or may not be. We're not real sure, just because the nature of the picture. Maybe it's kind of behind it, maybe it's next to the line, and maybe it's in Q also. So I couldn't have used that just because I don't know for sure. Right. All right, 3 collinear points. Is that one pretty easy? Yes. So 3 collinear points. What are those? I gotta look at my picture. U, V, W. Right. You have to look at your own picture. So I can. All right, 3 non-collinear points. Just give them to me. U, X, and Y. I think I heard that'll work. Are there other options? Yeah, but we'll have to do them all. A set of coplanar points. All right, so let me ask you this. Could I use U, Y, and Z? U, Y, and Z. Yeah. Because any 3 points are coplanar, right? I could make those might not be the ones that you would choose, but I could choose any 3 letters in the universe. Of course, this means at least from this picture, but any of them would work. A set of non-coplanar points. How many do I have to name to make sure they're non-coplanar? 4. Remember, any 3 are coplanar, so I have to have 4. So what about U, X, Y, Z? Y'all okay with that one? Okay. But let me ask you this. Are you for sure that X wouldn't be in that plane? Because X is kind of out there. You're not real sure about X, right? Could I use Z and V? Okay. U, V, Y, and Z. Okay. All right. The plane, if I got to name a plane in a different way, I have to use what? 3 non-collinear points. Okay, good. Have a great day. Don't forget your homework.